Hello again. We're continuing our discussion on solving systems of equations. We've talked about how to graph them, how to use substitution. We're going to move on to a third way called elimination. And there's two steps to this. Today we're just going to talk about how to solve by using elimination, and we're only going to use the operations of addition and subtraction. Okay. Tomorrow we'll move on to multiplication and division if that becomes necessary. So here are the steps that I would follow to do that. The first thing I need to do is make sure that both equations are in standard form. So x's and y's are on the left and there's a constant on the right. And I may need to do some rearrangement to do this, like adding or subtracting some terms from both sides just to make sure everything is in the right place. So I also need to make sure that the coefficients of one of the variables are either the same or the opposite. So looking at the x's, maybe one of the coefficients is 2, and that means that the other one would have to either be 2 or -2, so the same or opposite. Or if it was the y's, if the y coefficient was 3, then the y coefficient for the other equation would have to be 3 or -3, either the same or the opposite. That's how I can make this work. If that doesn't happen, if I don't have that, we're going to talk tomorrow about how to make that happen so that you have either the same or opposite coefficients in front of either the x's or the y's. Okay, so if I do have opposite coefficients, I'm going to add the equations together. And if the coefficients are the same, then I'm going to subtract the equations. Okay, and then what's going to happen is, if I add or subtract those equations, one of the variables is going to be eliminated, meaning that the resulting equation is only going to have one variable in it. And so I solve that equation for the new variable. So now I have the value of one of my variables, so I just need to plug that into the other equation to get the value of the other variable. But let's do some examples to clear this up. We'll start with 2x plus 3y equals 23. And 5x minus 3y equals 5. I'm hoping there's an x and a y that I can plug into either equation and make true statements out of them both. That's kind of the whole point of doing any system of equations. So the coefficients of the y's are opposites. If you look at the y in the first equation, it's got a coefficient of +3. If you look at the coefficient of y in the second equation, it's -3. So since they are opposites of each other, I will add the equations together. And I just add straight down. I'll look down each column and add the coefficients together and put the letter beside it, just like you would do anytime you add like terms. So adding the x's, 2x plus 5x is 7x. 3y minus 3y is 0y. So I don't need to write that. And 23 plus 5 is 28. So I get the equation 7x equals 28. And now that's a whole lot easier to solve because there's only one letter there. And I need to do a simple division to do that. If I divide both sides by 7, the 7x becomes an x and the 28 becomes a 4. So my x value is 4. So now I have half of my solution. I have the x, I just need to figure out the y. But since I know that x is equal to 4, I can go back to any original equation and replace x with 4, and that's going to give me an equation that just has y in it. So starting with the first equation that I was given, 2x plus 3y equals 23, that's going to become 2 times 4 plus 3y equals 23. I know that 2 times 4 is 8, so I can change that. So 8 plus 3y is 23. And now it's a multi-step equation. I'm going to add -8 to both sides, and I get 3y equals 23 minus 8, which is 15. And the last thing I need to do is divide both sides by 3. So that the 3y becomes a y and the 15 becomes a 5. So the solution to that system is 4 and 5. X is 4 and y is 5. That's the only x and y that I could plug into both equations and create true statements out of them both. No other x and y is going to do that for me. All right, so here's some more examples. 4x plus 3y equals 25 and 4x plus 3y equals 21. Well, the coefficients of the y are the same, and the coefficients of x are the same as well. So either way, I want to subtract these two equations. And if I do that, 4x minus 4x is 0, and 3y minus 3y is 0, and 25 minus 21 is 4. So I get absolutely nothing on the left-hand side, and I get 4 on the right-hand side. So I have an equation of 0 equals 4. Okay, well, there's no variables in this equation. All it says is 0 equals 4. So that's never true. So there's no solution to this system of equations. There's no x and y that I could plug into both equations and create two true statements out of it. It just doesn't happen. So here's another example. 4x plus 3y equals -25, and negative 4x minus 3y equals positive 25. Well, now the coefficients of x are opposites and the coefficients of y are opposites, so I'm going to add the equations together. The 4x plus the negative 4x is 0, and the 3y plus the negative 3y is 0. So again, I have nothing on the left, and the negative 25 plus 25 on the right, that's also equal to 0, so I have 0 equals 0. Again, there's no variable in this equation, but 0 is always equal to 0. This statement is always true. So what that means is there's infinitely many solutions. Any x and y that's a solution to the first equation is also a solution to the second equation. Okay, so there's infinitely many solutions. Let's look at a real-world example. I have a food stand that sells hot dogs and bratwurst dogs. And I know that if I buy 2 hot dogs and 5 bratwurst dogs, that costs $17.20. If I buy 2 hot dogs and 8 bratwurst dogs, that costs $25 exactly. So I just want to know how much each item costs. So I'm going to let H represent the cost of a hot dog and B represent the cost of a bratwurst dog. And so if I have 2 H's, or 2 hot dogs, and 5 B's, 5 bratwurst dogs, that's $17.20. And if I have 2 hot dogs and 8 bratwurst dogs, that's $25 exactly. Well, if I look at my H coefficients, they're exactly the same. They're both 2, so I'm going to subtract these equations to get the B variable by itself. Okay. So if I subtract the equations, 2H minus 2H is nothing, and 5b minus 8b is negative 3b, and $17.20 minus $25 is negative $7.80. Okay, so now I have a much simpler equation. It's only got one letter. So if I divide both sides by negative 3, I get that b is equal to $2.60. So I now know that a bratwurst dog costs $2.60. I can use that information to figure out the cost of a hot dog. Okay, so b is $2.60, so any equation that has a b in it, I'm going to replace with $2.60. Doesn't matter which equation I use, so I'm going to use the first one. 2h plus 5b equals $17.20, and that becomes 2h plus 5 times $2.60 equals $17.20. I can do that multiplication of 5 times $2.60 and get $13. So 2 hot dogs plus $13 equals $17.20. And if I add the negative $13 to both sides, just to get rid of it on the left-hand side, I have that 2 hot dogs cost $4.20. Divide by 2, and I get that 1 hot dog costs $2.10. So I now know that hot dogs cost $2.10 each, and bratwurst dogs cost $2.60 each. So that is systems of equations where all you have to do is add or subtract the equations to solve. We'll get into more complicated things tomorrow when we have to actually multiply or divide to get the coefficients of one of the variables to either be the same or opposites. So that's what you can look forward to tomorrow. If you have any questions, please let me know, and I will see you tomorrow.